Hello, dear friends. I welcome all of you in second online lecture of chapter 3 on D block element for Sybsc chemistry paper first, that is CH301 physical and inorganic chemistry. I welcome all of you from behalf of my college, that is Arts, Commerce and Science College, Bothwad. Myself, Professor Kanchan Damade from Department of Chemistry of Arts, Commerce and Science College, Bothwad. Now, in this second online lecture, we will discuss about chapter 3 of chemistry paper first, that is D block element. See the introduction of D block element. First, see the definition of D block element. Simple definition is the element in which last electron enters into d orbital of penultimate shell are called as D block element. What is penultimate shell? See in the image that penultimate shell is a second last shell. Second last means last shell is a valence shell and the second last one is a penultimate shell. If the valence shell has fifth energy level, then penultimate shell will have fourth energy level, that is n minus 1. N is a number of energy level of valence shell. Last shell is considered as n and second last shell is considered as n minus 1. So if last shell has energy level third, then penultimate shell has energy level 2, that is n minus 1. So again we will see the definition of D block element. The element in which last electrons enters into d orbital of penultimate shell are called as D block element. Penultimate shell will be a D shell and it is a second last one. Remember this. Now see the positions of all the element according to the different blocks in a periodic table. See, yellow color represent S block element. So S block element is present in group 1 and 2. Again the yellow color is represent P block element. They are present in group 11 to 17. The grey color represent D block element. They are present in group 3 to 10. And again the yellow color represent F block element and they are called as inner transition element. S block and P block element is represented as representative element and in between that the D block element is present, that's why they are called as transition element. See the last group 18, which is represented by grey color, they are called as noble gases, that is inert gases. Now this is the distribution of element according to the various blocks in periodic table. So there are a total 5 blocks: S block, D block, P block, F block, and last one is noble gases. Now see the classification of D block element. These elements are classified in 4 series. So first series is called as 3D series. 3D series contain 10 elements from scandium to zinc. Scandium has atomic number 21 and zinc has atomic number 30. Now second series, that is called as 5D series, contain 10 elements present from yttrium to cadmium having atomic number 39 to 48. Third series is called as 5D series having 10 element, contain element from lanthanum and ends up to hafnium. Lanthanum has atomic number 57 and hafnium has atomic number 72. The fourth series, that is 6D series, also contain 10 element. They are present from actinium to eurobium. Actinium has atomic number 89 and eurobium has atomic number 112. So in this way there are total 40 element in a D block of periodic table, and D block has 4 series, 3D series, 4D series, 5D series, 6D series. So this is a bifurcation of 10 element in D block of periodic table. Now see the classification of D block element in this image. This image shows 4 rows: 3D, 4D, 5D, 6D. 3D series start from atomic number 21 and ends up to atomic number 30. 4D series start from atomic number 39 and ends up to atomic number 48. 5D series start from atomic number 57 and ends up to atomic number 18. So when it is start from 57, the second element has atomic number 72. So the element in between 57 to 72 are written in 6th period of F block element. So the element between atomic number 57 and 72 are F block element. So there is an interruption in atomic number from 5D series, that is we can see here right from 57 we see the atomic number 72 hafnium of hafnium, because the element in between 57 to 72 are entered into F block element, that is they are all lanthanides. Same it is seen into 6D series also. The first element is represented by atomic number 89 and the second element has atomic number 104. So the element in between 89 and 104 are comes under F block element and they are called as actinides. So 5D series and 6D series has some interruption of atomic number from 57 to 72. Right from 57 we can see atomic number 72. So this is some irregular pattern of D block element. Now see next position of D block element in periodic table. So what is the position of D block element in periodic table? We have already discussed they are present in between S block and P block element. You know where is S block element and where is P block element. S block element are present in group 1 and group 2 of periodic table, and P block element are present in group 11 to 17. So transition elements are present in between S block and P block. Also in period of periodic table, the atomic numbers, or we can say all the element of D block element are present from group 4th to group 7th. That is all the 4 series of D block element are present in 4th period, 5th period, 6th period and 7th period of periodic table. Same way, if we see according to the group of periodic table, the D block element are present from group 3B to second B, that is from group 3 to group 12. So this is the distribution of d block element according to period and group of periodic table. You know what is period? Period is a horizontal row of periodic table and group is a vertical columns of periodic table. So see the position of d block element in periodic table. Remember that d block element in period they are present in 4th, 5th, 6th and 7th period, and according to group they are present in group 3b and ends up to group 2nd B, that is group 3 to group 12. So this is the position of d block element in periodic table. Now see the transition element. What are transition elements? So transition elements are nothing but they are d block element. They are called transition element because they are present in between S block and P block. D block element are in middle of S and P. That's why they are called as, they are present in transition position of S block and P block. That's why they are transition element. Now, general properties of transition element. See, first property of transition element is they are d block element. Second, the penultimate d subshell is incomplete. They have variable oxidation state. They are called transition element because they are present in between S block and P block. See the third property, they have variable oxidation state. What is variable oxidation state? See in this picture, variable oxidation state means all the element has changing oxidation state. What is oxidation state? Oxidation state means the state acquired by any atom after loss of one or more electrons. So if any atom lose one electron, then they acquire +1 oxidation state. If any atom lose 2 electron, then they acquire +2 oxidation state. So d block element has variable oxidation state, means they have more than one oxidation state. They have different oxidation state. See the scandium has two types of oxidation state, +2 or +3. Titanium has 3 oxidation state, that is +2, +3 and +4. Vanadium has 4 oxidation state, that is +2, +3, +4 and +5 also. Chromium has 5 oxidation state, that is +2 also, +3 also, +4 also, +5 also, +6 also. Dear student, kindly have a look on the picture. Manganese has largest number of oxidation state, that is +2, +3, +4, +5, +6, +7 also. Same way of iron, copper, nickel, cobalt and zinc. So all the d block element has variable oxidation state, means they have different types of oxidation states. Now fifth property of d block element is they have general electronic configuration is n-1 d at the power 1 to 10 n s 0 1 2. n-1 is a energy level of d, that is penultimate shell. 1 to 10 is a number of electron which is present in d orbital. ns012 012 is a number of electron present in s shell. S shell maybe have 0 electron or maybe 1 or maybe 2. So this is the general electronic configuration of d block element. It can represent all the element of all the series of d block elements. Sixth property is zinc, cadmium, mercury and copernicium is not a d block element because of completely filled d orbital. Completely filled d orbital means the d orbital has all 10 electron. The d orbital has completely filled electronic configuration. means if d orbital contain 10 electron, it is said as it is completely filled. See in this picture, zinc, which has atomic number 30, has electronic configuration argon 3d10 4s2. 3d10, 10 means d is completely filled. Maximum number of electron which is filled in d orbital is 10. So also see in cadmium. Cadmium has atomic number 48. The electronic configuration is krypton 4d10 5s2. Again cadmium has d10 configuration. So d10 configuration is a completely filled configuration. Completely filled means highly stable configuration. Mercury. Mercury has atomic number 80. Has electronic configuration xenon 4f14 5d10 6s2. So mercury also has d10 configuration. So d10 is a completely filled. That's why zinc, cadmium, mercury and copernicium is not a d block element, because they have completely filled d orbital. Now see the electronic configuration of first series of transition element. Last two shell 3d and 4s are incomplete. See in the picture, 3d and 4s are incomplete. Regular filling of 3d subshell but irregular in chromium and copper. 3d subshell is regularly filling, that is, in scandium 3d has 1 electron, in titanium 3d has 2 electron, in vanadium 3d has 3 electron, in chromium 3d has 5 electron, in manganese again 3d has 5 electron. So chromium should have 3d 4 configuration, but it has 3d 5. So it is a irregular filling. Again in C iron, 3d has 6 electron, cobalt has 3d 7 electron, nickel has 3d 10 electron, copper has 3d 10 electron, but it should be 3d 9, but in place of 3d 9 it is 3d 10. So chromium and copper has a irregular filling of electrons. This is due to more stability of half filled d5 shell and completely filled d10 shell. See, chromium should have 3d 4 electrons electronic configuration, but it becomes 3d 5 because 3d 5 is a half filled and it has more stability than partially filled. See in copper, copper should have 3d 9 configuration, but it is 3d 10. It becomes 3d 10. Why? Because 3d 10 is a highly stable configuration. So copper prefer 3d 10 configuration rather than 3d 9. So 3d shell completed at copper, 3d 10 or 3d shell is completely filled at copper. So general electronic configuration of 3d series is argon 3d 10, 3d 1 to 10, 4s 1 or 2. Means 3d should have electron 1 to 10 and 4 has electron 1 or 2, either 1 or 2. The electronic configuration of zinc is argon 3d10 4s2. Here 3d10 configuration is completely filled or highly stable, that's why zinc is out of d block element. As d shell is completely filled, that's why it is out of d block element. They are not considered as a transition element. So this is the electronic configuration of first series of transition element. So for more understanding, see the trick to learn d block element in YouTube. This is the topic of that video, and I am thankful for patience watching. Please stay home, stay healthy at your home. Now we will see one video on YouTube. Let's have a look.